So in this video, we're going to cover the fundamentals of the Detmolder Two-Stage Rye Sourdough feeding. This is a method that's practiced widely throughout Germany and Austria. I have a preference for this particular method because it fits in well with a commercial production environment and has more complexity and flavor than a one-stage feeding, yet it's not as laborious as a three-stage feeding. And the sourdough also can serve as a leavening agent, so there's no need to use commercial yeast in conjunction with this particular sourdough. The first stage in the sourdough feeding is called the base sour or Grundsauer, and its environment is cool and stiff, meaning that we're going to use cooler water and there's going to be less water than flour in the mixture. It's going to mature for a longer period of time. And this cool, low hydration environment really favors bacterial fermentation. So its aim is to develop acids, acetic acids. We're lowering the pH level in the sourdough, and we're also developing its flavor. The second stage is called the full sour or Vollsauer, and it has a warm, liquidy environment, meaning we're using warmer water. The hydration, there will be more water than flour in the mixture, and it's going to mature for a shorter period of time, during which we're favoring yeast fermentation. So this warm, liquidy environment favors yeast fermentation. And here we're duplicating yeast. We're building kind of more lactic acids to balance out the acetic acids that were developed during the base sour, so we're balancing out the flavor profile, and we're also supporting the sourdough's leavening power. I'd like to go over a few terms that we're going to use in our calculations. Hydration in German is represented by TA or Teigausbeute, which means dough yield. And the important thing to remember here is that flour is always equal to 100%. So in an example where you have 100 grams of flour and 100 grams of water, in the US that would be 100% hydration. We'll simply add the two together. 100% flour plus 100% hydration equals 200. So TA 200, TA 200. If you had 100 grams of flour to 70 grams of water, your hydration would be 70%. So 100% flour plus the 70% hydration equals 170. The amount of mother that one uses is also expressed differently in Germany. In German, that's represented by ASG or Anstellgut. In the US, we would typically express the mother as a ratio. So we would have, let's say, a 1 to 10 to 10 feeding. 1 part mother to 10 parts flour to 10 parts water. Or 1 to 2 to 2, 1 part mother to 2 parts flour to 2 parts water. In the case of 1 to 10 to 10, in the German version, you would look at only the 1 to 10 part of it, the 1 part mother to 10 parts flour. And that 1 to 10 ratio is equal to 10%. 1 of 10 equals 10%. A 1 to 5 to 5 would be 20%. Typical percentage of mother used in a Detmolder Two-Stage Rye Sourdough feeding would be 3, 5, or 10%. The longer the maturation time, the longer the fermentation time of the base sour, the lower the percentage. And the shorter the maturation time, the higher the percentage. You can also adjust the amount of mother you use to develop the type of flavor profile you want. So if you want a stronger sourdough flavor, you would use a higher percentage of mother. In our particular example, we're going to use 5%. That's a middle of the road lead time, maturation time, and flavor profile. So let's get to it. Let's say that we need 4,000 grams of sourdough culture for our recipe. And our sourdough will be 125% hydration, or Ta225. So it's going to be very liquidy. Here I'm going to enter in the amount, 4,000, but I want a little bit more than that left over so I can feed it the next day and build upon it. We don't want to use all of our sourdough. So I'm going to make maybe 3% more than what's needed. So that gives us 4120. That's how much sourdough we want to build. Now let's figure out, well, how much flour and how much water is that? If it were equal parts flour and water, that would be pretty easy. You would just divide that number by 2 and you would have equal parts flour and water. But in this example, our final sourdough will be 125% hydration. So we're going to take the 4120 and divide it by 225 units and multiply that by 100%. Flour is always equal to 100%. That equals 1831. We'll do the same thing for water. We'll take 4120, divide that by 225 units, and multiply that by 125%. And that equals 2,289. Just to cross-check, the two components, flour and water, equal to 4120. That's how much sourdough we need. So let's go to our first feeding. Our base sour will be at 70% hydration, or Ta170. So let's figure out how much water and flour we need to feed. So we'll start with the flour. Typically in your base sour, you acidify 1/3 of your flour. So this will be equal to the 1831 divided by 3. Gives us 610. And now we'll calculate our water. Our base sour is at 70% hydration, so we'll take our flour and multiply that by 0.7. Now the amount of time, we're going to let this ferment somewhere between 12 to 16 hours. And our desired temperature is around 75 Fahrenheit, which is about 24 Celsius. So based on this lead time, this middle of the road lead time of 12 to 16 hours, we said that we're going to use 5% as our inoculation, Anstellgut. So we'll take our flour and multiply that by 5%. So we're going to start with 31 grams of mother, and to that we're going to add 427 grams of water and 610 grams of flour. If your lead time were longer, you would simply decrease the percentage of your Anstellgut from maybe 5% to 3. And you would start out with 18 grams. But in this case, we'll revert it to 5%. So after the 12 to 16 hours of developing the base sour, it's now time to feed, to build our full sour, our full Sauer. So we're going to take all of our base sour and we're going to feed it more flour and water. So we're going to calculate the flour simply by taking the difference of what we need at the end minus what was in the base sour. And we'll do the same thing for water. Now the time for your full sour is relatively shorter. It's going to last about 3 to 4 hours. Oops. And we're going to have a higher temperature of the mixture. So 90 degrees Fahrenheit or 32 degrees Celsius. This is pretty much on the highest end. If you had a lower temperature, your maturation time would be longer. Now, you can really change any of these factors. You can change your temperature. You can change your hydrations. So, for example, if you wanted a more sour flavor profile, you could either use a lower temperature, or you could use more mother, or you could decrease your hydration in your base sour. All three of those things would promote having a more acidic flavor profile. Same thing if you prefer a less liquidy full sour, you can decrease your hydration. Or you can amend the temperature if you need more lead time. You can lower your temperature to build more lead time to fit into your production schedule. This is simply an example of what the Detmolder Two-Stage Rye Sourdough feeding can look like. If you have any questions, please let me know.